right, welcome to my class today, Drip Academy. We want to do justice to naming organic compound. We call it IUPAC nomenclature. Now, if you're given a condensed organic compound like this, and you're asked to provide the IUPAC name for this compound, for students who don't have a good foundation, the first way for you to be able to see what it is built up of is to be able to present a skeletal representation. Now, how do we begin? Let's go. And the first one here is carbon. Carbon has 3 hydrogen. So these are the 3 hydrogen, all about carbon. The next component is 1 carbon. It has just 1 hydrogen, meaning that the second hydrogen has been replaced by a substituent, which is a methyl substituent. So this is the 1 hydrogen, then we have CH3. Yes, so this is the next carbon. It has 2 hydrogen. Perfect. 1, 2. The next carbon has just a single hydrogen, meaning that the second hydrogen has been replaced by an ethyl substituent. So we have H, C2, H5. Okay, the next carbon has 1 hydrogen as well, and the next substituent is OH. And so we have the last carbon having 3H. This is beautiful. This is the skeletal representation of this organic compound. Now, looking at this now critically, one could see from this expression that we have 3 substituents. This is a substituent, this is a substituent, and this is a substituent. So this substituent is methyl substituent. Why? Because it has lost a hydrogen. Why this is ethyl? Ethyl substituent, because it has also lost a hydrogen from the initial ethyl ethane group. This is the hydroxyl representative, giving it an alcoholic functional group. Yeah. So how do we name this now? Looking from both sides, we discovered that we can begin from this part of the naming or this part of the naming, but then there is something very important. And the important factor here is we begin with where the functional group is closest to the H, which is OH. We also have methyl group here, but then in terms of precision and requirement, OH should be the focus for where we are going to begin the naming from, because this gives this whole compound its chemical property and its representation. Therefore, this becomes the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. And that means this is a hexane primary chain. This is a hexane parent chain. Yes. So OH is on carbon number 2. Keep that in mind. Ethyl group is on carbon number 3. Also, don't forget about it. Methyl group is on carbon number 5. So how do we name this now? 3 substituents. So we have methyl and ethyl. The both of them have alphabetical representation quite different. Methyl begins with M, ethyl begins with E. So what it means is that alphabetically, from one of the rules of IUPAC nomenclature, is E comes before M. So that means we are going to mention this, the position of this, before this. So how is the name going to be now? Based on alphabetical representation, ethyl group is on position number 3. So we say 3, right? Between the number and alphabet, you separate it with a hyphen. 3, ethyl. Good. Now, the next substituent is methyl on carbon number 5. So we said a hyphen again, 5, methyl. Perfect. Now, we have the parent chain. Alright, so the parent chain now have OH group, meaning it's hexanol. Yes. So we can have hexanol. Now, this is perfect. We have been able to do justice to this, but then there is another way this name or this IUPAC name nomenclature can be represented. It can also be 3-ethyl, good, 5-methyl, hex, 2-ol. Yes, because the hydroxyl group is on position number 2. So you can call it this way. Alright? Perfect. So I believe we have done justice to this and somebody have gained something right now. Thank you so much. God bless you. Always don't forget, success is only for the brave. Congratulations.